Well, as we start chapter 7, we're going to be discussing chemical reactions. Now, a lot of people tend to think that chemical reactions are something big, like an explosion or like fireworks, but in reality, chemical reactions are happening all around us every single day. For example, when you cook, you're creating chemical reactions. The photosynthesis that's happening in the leaves for them to create the food that they need, that is a chemical reaction. If you see something rust, that's a chemical reaction, as well as fireworks when they explode and make lots of light and lots of noise. That's a chemical reaction too. So do you remember the physical and the chemical properties that we discussed back in chapter 2? Chemical properties were properties that we said that you couldn't tell about a substance unless you changed the substance. We said a physical property was something that you could measure without changing it. Something like its mass, its volume, its density, what color is it. Those are all physical properties. Its state of matter, whether it's a solid, a liquid, or a gas, that's a physical property. But a chemical property is one that you can't tell if a substance has it or not unless you actually change the subject, or change the substance. So if you have a substance and you want to tell if it's flammable or not, the only way you can tell if it's flammable is if you actually try to burn it. And if it is flammable, then once you burn it, it's not going to be the substance that it started with. Reactivity is going to be the same way. You're not going to be able to tell if a substance reacts with something else unless you try it. And if it does, then that substance is no longer what it started out to be. So everything that we talk about in this chapter is going to be a chemical reaction where one substance is changed into another substance. So as an example, the photosynthesis that I mentioned earlier, the plant takes carbon dioxide and water and it changes those things into a simple sugar and oxygen. If you see something that is rusting, that's a chemical reaction in which iron has been turned into an iron oxide, which is what we commonly call rust. If you have bread dough and you put it in the oven and you bake it and it turns into bread, that's a chemical reaction. And if you have a pile of chemicals and you light it and it explodes and makes all kinds of pretty colors and loud booms in your fireworks, that's a chemical reaction. So the first thing we want to talk about today then is what the signs of a chemical reaction are. How are you going to know for sure if a chemical reaction has taken place? Some reactions are very, very slow and some of them are very quick. So how can you tell for sure if that's what it was? Well, one of the first signs of a chemical reaction, and it won't happen in all of them, but sometimes you're going to see bubbles happen. And if you see bubbles, what that means is that a gas has been formed. Now, you have to be careful with this particular sign of a chemical reaction because when something boils, like if you put water on the stove to boil because you're going to make spaghetti, that liquid will start boiling and you'll see bubbles in it. That is not the same thing as a chemical reaction because all that's doing is changing state. So that's one thing that you have to watch carefully. Maybe when you were in elementary school, you made one of those really cool volcanoes where you took baking soda and vinegar, and when you put the vinegar onto the baking soda, it bubbles. That's the type of bubbles that I'm talking about. Your book also mentions that odor is a sign of a chemical reaction, but in reality, if you're going to smell something, it's because there's a gas in the air and your nose is picking up those gas molecules that are in the air. So the gas forming could be bubbles, or you could also smell an odor to that as well. But some of those gases that are formed don't necessarily have an odor. So example, I mentioned the baking soda and the vinegar. When you put those together, that produces carbon dioxide. Carbon dioxide doesn't have an odor to it. Other types of gases that can be formed, like hydrogen sulfide, that one smells like rotten eggs. And so if you smell something like that, you can know a chemical reaction has taken place. So again, this one's one you have to be careful about because just because you see a gas doesn't necessarily mean it's a chemical reaction because it could be a change of state. And a gas could be formed without there being an odor there as well. So that's one thing that you can look for to determine if a reaction has taken place is if you see any bubbles. The second sign of a chemical reaction is a precipitate. And this one is a little bit harder to explain to you because it's not something we see really, really often just in everyday life. But what happens is that you take two liquids and you pour them together, and there's a solid formed as a result of that. And in video number 2, I'm actually going to show you an example of what that looks like. So kind of hang tight until we get there. The third sign of a chemical reaction is a color change. And I have already mentioned rusting today. And you know that if something rusts, the color is not what it was before it rusted. So that is an example of a color change. A fourth example, your book mentions this one, is a composition change. And probably the best example of that is what happens once something burns. If you take a log and you burn it for your campfire, then what you have left is a pile of ashes. And so obviously that composition looks very different from what you started with. So a composition change is going to signify a chemical reaction. And then lastly, there could be some sort of an energy change. And this can happen in one of two ways. You could either have an absorption of energy or you could have a release of energy. So we'll talk about both of those separately. If you have an absorption of energy, that means that the chemicals or the substances that are reacting have to draw in energy from the surroundings. So if you've ever seen a cold pack where a lot of times coaches will have these and a player gets injured and they take this pack and they scrunch it together and then it gets cold. That's called an endothermic reaction, and that means that the substances have absorbed energy from the air in order to react. So if something gets cold, the temperature really drops. Endothermic. That's an example of a reaction. Now, on the other hand, in place of absorbing energy from the surroundings, you may have energy being released from the reaction itself. And so an example of that, similar to the cold pack example, is I know I've seen some of these packs where if you kind of scrunch them together, then what happens is they start to get really, really warm, and people will put them in their gloves to keep their hands warm in the wintertime. And so if you have a release of energy where something is getting warm or getting hot, it's releasing that heat energy from the reaction, that's called exothermic. And so it's going to be giving off the heat. You may also see a release of energy in the form of light. Some of these glow sticks, I know my grandkids like playing with glow sticks. They're a lot of fun. And so you see these things that will give off light once they're activated. Also, if it gives off sound, like fireworks, so light and sound, especially in the case of fireworks, that gives off a tremendous amount of energy, which is why you need to stay back when you're setting them off, because certainly that all that energy can injure somebody. So a release of energy, whether it's getting warm or whether it's a release of energy in the form of light or sound, is also going to be a sign of a chemical reaction. So this is, again, it's not quite as many signs as you will see in your book, because I've kind of combined some of them together. I think it makes a little bit more sense that way, especially the odor one up here. So if you see bubbles, if you see a precipitate, if you see a color change, if you see a composition change, if you see an energy change, whether energy is either absorbed or whether it's released, those are all signs of chemical reactions. And when we work on experiment 7.1 tomorrow, you're going to get to see a lot of those signs of chemical reactions.